Okay, can everyone see my screen?
Yes, perfectly.
Okay, I apologize for my Portuguese disability. This talk is very personal. It is Phelan Mcdermid syndrome, a journey. And so the first part of this journey started, of course, with my son, David. And this is David and his father. David had recently come home from the hospital. He has tubes for oxygen and food, but he was very happy. I apologize for the sounds. So as a young baby, he spent his first 2 months in the hospital.
No hospital. Esse é o tamanho de
syringe, so he was very small, premature child. But after he was home for a little while, we could disconnect him from his oxygen. Here's a picture of David with his mother. And he was very eager to learn. He was a hard worker. And so here's David. He used the refrigerator. This is where all the food is. And he would crawl up to the refrigerator. He would open the door. He would use the wire to move his finger, to hold his fingers. And this is how he learned to stand up. He taught himself to stand up. Now, we also had a physical therapist, and so we were working with him every day, but he also worked on his standing on his own. He was late in all his milestones. He was age 4 by the time he could stand on his own. He was able to walk at age 6. It was not until he was 9 years old before we could finally eat all his calories by mouth. He was never able to talk, and he did some communications with pictures. Here are some of the pictures that we used with him. Here's his backpack for going to school, some foods, drinking and eating, and he loves videos. To this day, he loves videos. When he was in school, there was a lot of difficulty getting his education. And I think this is common for a lot of families. I don't know. But this is just 3 of the years he was in school, showing either no significant progress or negotiation with the school to get sufficient support for his education. And even when we won in 1997, we had to start all over again in the next year. This is David as a teenager. His diagnosis was that when he was age 15, that was around the year 2000, and I'll talk about that in a few minutes. But at age 17, he could walk pretty well. Here he's out walking with his mom. And here he is, age 19, traveling with the family.
Quando viajamos com a família. É muito confortável na sua posição, assistindo os vídeos. Essa é uma foto, eu gostaria de dizer que tivemos um momento incrível nas nossas vidas. Quando ele tinha 18,
we found a summer camp, and David went away for 2 weeks at a time, and they took care of him 100%. This was his last year there, and this was his counselor. and they were so loving and caring and hardworking. It was a wonderful experience to see him, with all his disabilities, still have a place to go. I wonder if other people in this group have done what we did. This is 11 pages describing all the detail of what you need to know to take care of David. This was called The Secrets to His Care and Feeding. And it was the document we made for the summer camp. David's now 35 years old, and I thought I'd give some pictures as an adult. Here he is at a Phelan Mcdermid Foundation conference 10 years ago. He was age 25. And here's another young man at the conference watching his video, and David quietly watching the video with him. Eric and David were very similar in many, many ways. And that was the amazing experience going to the conference, was to see other children, some of whom were very similar. Here he was visiting home at age 27. We tried to get him to wear glasses, but if you look, he won't look through the glasses. He never liked looking through the glasses. And here he is in his group home when I came to visit one time. And here he is now. This is during COVID. And during the winter months of COVID, before there were vaccines, David's father and mother, that is myself and his mom, were not allowed to visit him. We were not allowed to go inside with him. We were not allowed to touch him. We were not allowed to be within 2 meters. So he would come outside with his aide, and they would walk around the driveway, and we would be standing next to the car and talking to him. And we did that every Saturday. I went every Saturday. His mom went every Sunday to let him know that we were nearby. And now, with vaccination, I'm allowed to take David on rides. I'm allowed to take him to the park. He loves walking in the park. Here he is. He and I are together. Normally he holds my hand, but I had to let go so I could take a good picture. I wear a mask all the time, but it's wonderful to be back together with him. It was a very sad time for him and for his mom and myself. So this is part 2. I want to talk about a world journey, also connected with Phelan Mcdermid. So my family is from Poland. This is Eastern Europe. I'm sorry. So this is our family was originally from Poland, and we came to the West in two different periods. The travel to the United States and to Argentina occurred around 1900. And another travel, other family members went through Switzerland to Israel and Canada after the Second World War. Most of the family was lost during the Second World War, but some made it to Canada and Israel. Now, this actually is important to the understanding of Phelan Mcdermid syndrome. And I'll explain why in one moment. But first, I want to combine that with the history of Phelan Mcdermid syndrome itself. And you heard a little bit about this earlier today. The first case study was in 1988 by Katie Phelan and her colleagues at the Greenwood Genetic Center. And then several other cases came up. This is just one of them by Lonnie Zwagenbaum and his colleagues at University of Toronto. I'm sorry about this mark. I'm not going to worry about it for now. These were all cases of chromosome 22 deletion. And by 1994, Nancy Nessinger, also in Canada, recommended we give it the name 22q13 deletion syndrome. And in 2001, Katie Phelan and members of the Greenwood Genetic Center published these pictures, the first group of 37 children describing Phelan Mcdermid syndrome, and you've heard a little about that today also. I point out they were ages 3 through 24 in 2001, and now they're ages 23 to 44. So this was 2001. In the year 2000, there was a related paper on
Houve uma publicação relacionada sobre a síndrome da deleção do 22q13, que saiu da Universidade Johns Hopkins. E a descrição era sobre a mãe que tinha cromossomo
derivative chromosome 22. I wonder if I can bring up, there we go. There was a movement of, there was a displaced genetic material between chromosome 22 and 19, leading to abnormal chromosomes in the mother. And the daughter had what's called an unbalanced, this is called a balance translocation, had an unbalanced translocation, which gave the daughter 22q13. So the mother is a carrier. I received a letter from that mother. This is her daughter, Allie, with Phelan Mcdermid syndrome. This is my son, David. David is older than Allie, but I used here an older picture when he was a young child. And the letter came from my cousin. My cousin Deborah wrote to me and said, maybe your son has this. This is our grandfather, Joe. Joe lived with me actually in my parents' house for the last several years of his life. I knew him very well. He was a very rugged man, and he was originally from Poland. So I got myself tested and David tested to see if it was possible that we had the same chromosome error. And the test came out positive, and in fact, that started a new journey. I call this a journey through time. And we started putting together a family tree. And this family tree was I got help from Katie Phelan and some other researchers. And they identified people who were suspected of having 22q13 deletion syndrome, Phelan Mcdermid, and testing their parents or the children, and we got positive test results in many parts of the family tree. From that information, I built this model of the family tree. So this goes back 5 generations in my family. This is my family from Poland, from Europe. And their children, and the red lines show family members that carry the syndrome as a balanced translocation that is an abnormal chromosome. And here is my son. Here's Allie, our cousins, but there are other members of the family. And from the fact that these came from different grandparents, we were able to prove that it went back at least this far in the family. This was a very strange moment. This is the journey through time led us to understand our family better. Here's a picture, a photograph from 1930. And even though Phelan Mcdermid syndrome was not discovered until the 1990s and 2000, I know now that my grandfather was a carrier, my father was a carrier, my cousin's father was a carrier, and I don't show it here, but this is Florence. My father's older sister is another carrier. So this genetics allows us to look back through time and also speaks to what's going on in the world. There may be other people in the world who are related to our family who are carriers and have children with 22q13. So I want to go on to another part of the journey. This is part 4, what I call a scientific journey. And this picture is a picture I took when I was in graduate school before I had children. I was studying to be a scientist. My science was brain research, and I worked primarily with monkeys in brain research. But suddenly, with the birth of my child, I realized I needed to learn about genes and chromosomes. So I read a lot of material. Like all scientists, one thing you learn in graduate school is how to teach yourself. So I spent a lot of time reading textbooks and papers. And I came to realize that chromosomes and genes are not so complicated. The basics are very simple. So this is chromosome 22. And I would say that a chromosome is a box of recipes. So here's a box of recipes from the kitchen. And each recipe is a gene. So the chromosome is the box. Here's the gene. This is part of Shank 3 gene. And the gene is a recipe to build something the body needs. So I've used banana bread, and you'll see why in a moment. But one recipe is one gene, and it's to make something your body needs. I don't think it's much more complicated than that until you get into some of the details of what can happen on a chromosome. So one of my subjects has volunteered to help explain chromosome deletions. And we call this, "What have you done to my banana?" Although a chromosome can be thought of as a box of recipes, for the moment, I want you to think of a chromosome as a banana. And in 22q13 deletion, it's a bite taken out of the end of the banana. So here's the byte taken from the end. Here's chromosome 22. And the deletion is the loss of the genes in this part of the box. Once again, I don't think it's so complicated. This is Phelan Mcdermid syndrome. You've actually seen a drawing like this similar. And in fact, in one moment, I'll show you the drawing you saw before in the other talks. But this is from a paper by Sarah Sarasua at the Greenwood Clinic. And she took 71 patients with different size deletions. So each red line is a different byte from chromosome 22. I like to look at it this way, different size deletions. And she put them in order of small deletions to large deletions. The largest deletion is about 9 megabase. Here's a little bar. This is 2 megabase. So 22q13 deletion syndrome is really a syndrome caused by different size, depending on which person, pieces of the end of the chromosome have been removed, deleted. Now I bring this up because Maria Rita just explained this. And Claudia is here, I think, or was here. This is a similar study done on 29 patients in Brazil. And the results are essentially the same. Small deletions that included the Shank 3 gene cause Phelan Mcdermid syndrome. Different size deletions, which can destroy different number of genes, also cause Phelan Mcdermid syndrome. And I didn't show it here. In fact, it's not on this drawing in the paper. But in both studies, there were a few cases where there was a deletion in the middle causing Phelan Mcdermid syndrome that did not include Shank 3. And in both studies, if you look about right in the middle, an average size is about 4.5 megabyte is the average size deletion in the syndrome. So that's the story of chromosome deletions. And this is part of my understanding as a scientist, as I wanted to explore this and really understand what was going on with my son. So this is the simple model. And I took that model a step further in my first work with some colleagues. And I wanted to know three things. Three things seemed important. Number one is, which genes are involved in Phelan Mcdermid syndrome? The second question is, which of these genes are the most important? And the third thing I wanted to learn is, what do the important genes do? Because we need to know what they do if we're going to fix something. So this first study was a review of all the genes that are lost in the largest size deletion of Phelan Mcdermid syndrome. And the color is a hint at which genes might be important. This was a paper that was mentioned in a couple of other talks today. I got together with a different group, and we asked the question again, which genes are the most important? And we came up with this list. And so far, the list has turned out to be very correct, very accurate, so far as the subsequent science has been able to show. So all 18 of these genes are very important. And the question is, what do these genes do? So there are two genes, Shank3 and MAPK8IP2, that have to do with communications between cells, synapses. There's this gene that has to do with the proper pattern of cells. And proper organization is important in the brain because the brain is very organized, but it's important in the kidney, it's important in many, many parts of the body. These two genes change the way we have to think about Phelan Mcdermid syndrome. Phelan Mcdermid syndrome is not just about a few genes or 18 genes or even 100 genes that you saw in that first drawing. Each of these genes affects between 500 to over 1,000 other genes throughout the genome. BRD1 gene affects 1,500 other genes. TCF20, I don't know the number, but there is a whole syndrome, intellectual disability syndrome, if you have a disrupted copy of TCF20. So these are very important in their influence on the rest of the genes in the DNA. SALT4A1, it didn't seem like it fit in what it did. It does exist in the brain, but only in the last 2 years, we discovered it's a very important gene for mitochondria. It was never listed as a mitochondrial gene until work from 2 years ago. There is also evidence that this gene is a causal gene for Phelan Mcdermid syndrome in a small number of cases. And CELSR1, I just wrote a blog on that this last week. It's involved in patterning. It's involved in the growth of new brain cells. But they just discovered that it is very important in the recovery of the brain after an accident. So if you're missing this gene, you may not see a problem until there's been some brain damage. Then it would seem, from the research that's been done so far, your recovery from the brain damage, like a bleed or perhaps even a less severe head injury, is incomplete. And finally, I want to point out that these are the genes that we know about. But in between are the genes that we don't know. We're not sure what they do. We have some idea for ZBED4. There's a little bit of idea for some of these. This is, I think, used in the mitochondria, but I don't remember actually. But we don't have a lot of information on some of these genes. And there's no reason to think they aren't equally important. Just because we don't know what they do, doesn't mean we don't know that they're important. And there's another study that shows that when you have a whole group of genes with a high importance, what's called a PLI, when they have a high PLI, the more you delete, the worse the intellectual disability. So those are the genes. This is the list of genes. And we discussed what some of them do. Unfortunately, we don't know what all of them do. But a very important question is, which genes are deleted the most often? Because that gets at what makes a gene important. If it's only deleted sometimes, very rarely, then it's not as important as a gene that's deleted frequently. As I said before, an average size deletion is about 4.5 megabase. So these are the genes that are missing after an average size deletion. So I'm gonna mark our banana. We'll call that an average size deletion. Shank 3 is deleted not quite every time, but almost all the time. That makes Shank 3 very important. And finally, there are rare deletions that do not go to the end of the chromosome. This is the end of the chromosome here. These rare deletions, if they include certain genes, probably SULT4A1 is one of the most important. They cause Phelan Mcdermid syndrome. So these are not studied very often, partly because they're not involved very often, but that doesn't make them unimportant. These, we're getting more and more information every year. And most of the research is on Shank 3 because it's deleted every time in Phelan Mcdermid syndrome. Almost every time. And I want to give more reasons why Shank 3 is important.
Motivos para explicar por que o Shank 3 é muito importante. A primeira é que Shank 3 sozinho pode causar a síndrome de Phelan Mcdermid.
Second, only a few people with Phelan Mcdermid syndrome have a normal Shank 3. That's those people that we saw just a moment ago here in the rare deletions. Most people who have a significant disruption of Shank 3 have autism, intellectual disability, or some motor movement disability. Like some of the other important genes, Shank 3 is necessary for healthy brain development. This is before birth. And like some of the other important genes, Shank 3 is necessary for normal brain function after birth. So Shank 3 is clearly the most important gene in Phelan Mcdermid syndrome. It's only one of 18 genes, but it's the most important. I want to show this, but already this has been shown. This topic has been covered, and it will be again by Dr. Kolovsin in just a moment. These are all the known, or at least most of the known mutations or variants of the Shank 3 gene. This drawing is only the Shank 3 gene. This is the very end of the chromosome. This is in the picture of the chromosome, you can't even see this. This is expanded for just the Shank 3 gene. What's important here is that there are many places on the gene that when it's disrupted, it causes Phelan Mcdermid syndrome. So we have 3 classes, maybe 4 classes, but primarily 3 classes of Phelan Mcdermid syndrome. Deletions that can delete from 1 to 18 genes, including Shank 3. Very rare deletions that don't involve Shank 3. And these disruptions of Shank 3 that are often very, very small, very tiny, that cause Phelan Mcdermid syndrome. So that was my journey as a scientist. That's what I've learned, trying to be the best father I can. Like all of us, we're just parents. We're just trying to do our best. And each of us has our own unique abilities and our own unique worldviews. And I just wanted to share my view, and it happens to include science. But it was a family journey, and my family journey is not so different from other people here. And it doesn't matter if I don't speak Portuguese. It's the same journey. My family has an unusual world journey, and I don't believe there's any other Phelan Mcdermid family that's been studied as carefully as ours. And then the scientific journey. But there's a little bit more. This journey is a journey with other families. It's not just our family, and we don't walk alone. Here is a Facebook post I did, and 154 more people clicked on this Facebook to tell me that they are on this journey with us. This is a community. None of us is alone. So I want to thank you. I want to thank everyone here for joining our family on this journey.